Hello everyone, happy to see you here, welcome back to my channel. Today we have really interesting cubic equation a square minus a cube equal to 36. We need to solve this equation for a, so if you have your assumption, your solution, you can also write it in the comments below and then we will check your answer, so it will be really interesting to check it in the end of the video. Okay, so first of all, let's write the 36 on the left side. So this is our first step. So we have a square, so the same beginning, minus a cube, and minus 36 is equal to 0. Right now, this 36 we can write as 27 plus 9. A lot of students may be asking, why do we choose this expression? Why not like 18 plus 18, 20 plus 16? Just look at it. Just instead of this 36, let's write 27 plus 9. So let's do it. So we have a square minus a cube minus, instead of 36, we write 27 plus 9. 27 plus 9. And right now, I'm going to explain you why do we choose this expression. Why do we choose 27 plus 9? Right here in the beginning, we have a square and a cube. So we have square and cube. 27 is a really great constant for us because 27 can be written as 3 times 3 times 3. So we can write it as 3 cube. And 9, we can also write as 3 times 3. So we can write as 3 square. And when we add it, so 27 plus 9, we have exactly our value. We have 36. So it's also really great because then we're gonna group cubes and squares. So right now let's write this expression without parentheses, but with the negative sign we need to choose this one to the opposite one. So we have a square minus a cube minus 27 and minus 9. So I really hope you understand this first step. Secondly, let's change this 27. Let's change this by 3 cube, and instead of this 9, let's write 3 square. So it's not a substitution, this is the same value, but in a different interpretation. So a square minus a cube minus 27, 3 cube, and minus 9, 3 square equal to 0. Really great. As I said before, we're going to group, so we have a square and we have 3 square. We have a cube right here and we have 3 cubes. So let's group our squares and cubes. First of all, let's start with the squares. Let's do it right here. So we have a square minus 3 square, a square minus 3 square. So this is our first parenthesis. And second parenthesis, a cube plus 3 cube. So we have minus sign right here and a cube plus 3 cube. A cube plus 3 cube equal to 0. So I really hope you understand this solution until this moment, because right now we're gonna solve this question from a different angle. Right here we're gonna look closely at this expression because right here we have difference of squares, right here we have sum of 2 cubes. And sounds familiar, we should remember this formula from school because difference of squares, this is a very basic formula, maybe the most popular formula nowadays. We have a square minus b square. This is equal to a minus b, a plus b. This is all known formula, difference of squares, a plus b. And second formula, sum of 2 cubes. Everyone should know about this formula because maybe this is not the students doesn't use this formula a lot, but sum of 2 cubes is also really great formula, a cube plus b cube. As a result, we have a plus b, and second parenthesis, a square minus ab and plus b square. Really great. And right now let's apply this. Right here difference of squares, right here sum of 2 cubes. So let's start with that right here from the left side. So a minus 3, a plus 3 in terms of this formula difference of squares. So a minus 3, a plus 3, a plus 3. And second formula minus, right here we have sum of cubes. So let's write it as a plus 3. So I'm gonna apply it instead of a and b. I'm gonna apply this a and this 3. So I'm gonna apply this formula. A plus 3. Then I think we have a square. Yeah, we have a square minus 3a and plus 9 equal to 0. Okay, we applied this formula, everything is great. Right now let's look closely what do we have. We have a plus 3 right here, and we have a plus 3 right here. So we can actually factor this a plus 3 as a common expression. So let's do it right now. A plus 3 from the beginning, we're gonna factor it. So a plus 3 from the beginning, a plus 3. And in another parenthesis, we still have a minus 3 from here, so let's write it in another parenthesis, a minus 3. And from here we have this expression, minus a square minus 3a and plus 9. Really great. Right now, we can't simplify this more, so a plus 3, we'll leave it like that without any changes. So we have a plus 3, the same beginning. What about this parenthesis? We can actually get rid of this parenthesis, and we can actually get rid of this parenthesis, but we need to change all the signs to the opposite one because we have a negative, okay? So we have a minus 3, the same beginning, minus a square plus 3a and minus 9 equal to 0. All right, let's simplify this. Let's change in order because right here it looks like this is a quadratic equation, but we need to do a few more steps for it. So we have a plus 3, and in another parenthesis we start with minus a square, 3a plus a, so plus 4a, and minus 3 minus 9, we have minus 12, equal to 0. And the final step, of course, this is up to you, but we can multiply it by minus 1, so we can change all these signs to the opposite one, but this is not necessary, okay? Right now, let's look at this question from a different angle. We have a product of two parentheses. A product of two parentheses equal to 0 when the first parenthesis equal to 0, so a plus 3 equal to 0, or another parenthesis equal to 0, or this one, minus a square plus 4a and minus 12 equal to 0. So we have two equations. In this one, this is our linear equation. We can solve it without any problems. We can write that a first equal to minus 3 from here, yeah, minus 3. This is our linear equation, and this is our one. This is our first real number root. What about the second equation? This is a quadratic equation, but without any problems, we can easily solve it. First of all, we can multiply it by minus 1 because we prefer a little bit different order. So we have a square, minus 4a and plus 12 equal to 0. And right now we have a classic quadratic equation. I'm going to solve it according to a basic method of coefficients. So first of all, right here we have our coefficients, a equal to 1, b equal to minus 4, and c equal to 12. Right now let's plug in these coefficients into this spot. First of all, let's find discriminant. So b square minus 4ac, yeah? We have b square minus 4 square, minus 4 times a times 1, and c, we have 12. As a result, our answer, minus 4 square, we have 16, minus 48. So as a result, our discriminant is negative, so minus 32 is less than 0. So it means that in this branch, we will have two complex roots. So let's find it. We have a second and a third. So minus b plus minus square root of discriminant and all over to a, all known formula. And let's continue right here. So minus b minus 4 plus minus square root of discriminant square root of minus 32 and all over 2 times a, 2 times 1. Right here, what do we have? Minus, we have plus right here, so we have only 4 plus minus. Square root of minus 32, we can write as a product, so 8 times 4 or 16 times 2. Let's choose 16 times 2. So we have minus 1 in the beginning, times 16, and times 2, all over 2. Really great, so equal to. Right now we can split it. We can write it as square root of minus 1 times square root of 16 and times square root of 2. There's like one property. So we just follow this property right here, square root of minus 1 times square root of 16 and times square root of 2, all over 2. From here, square root of 16 equal to 4. Yeah. From here we have also 4. So 4 plus minus 4. Right here we have I and square root of 2. All over 2. This is our imaginary unit. Maybe a lot of students here, so I just want to explain it step by step. Okay, and finally, let's divide our numerator by part. So by 2, so we have 4 over 2. We divide it because we need to separate it, and we need to a point where do we have real part and imaginary part. So 4 over 2 plus minus 4i square root of 2 over 2. From here we have 2, and from here we have also 2. So our final answer, 2 plus minus 2i square root of 2. Okay, and these are our two complex roots. And let's gather all the roots together and let's write our final answer to this question. So our our answer to this question. So first of all, our a first equal to minus 3, this is our first root, and 2 complex root a second and third equal to 2 plus minus 2i square root of 2, 2i square root of 2. Of course, right here we have real part and imaginary part. Maybe you need it, and maybe you're interested in this, exactly in this case. So it was my solution to this question. Finally, let's check real quick our a first equal to minus 3. This is our only one real number root. This is our complex root, so we don't need to check our complex root. Let's check real quick our real number root. So let's do a proof, let's do a quick check. And we have a square minus a cube equal to 36. Right now, let's check real quick our a first equal to minus 3. So we have minus 3 to the power 2 minus 3 to the power 3 equal to 36. So we need to do it step by step because we have a lot of powers, a lot of negative signs, but without any problems. Minus 3 square equal to 9. Minus equal to plus, because we have an odd power. Even if you keep this negative sign, right here we also have minus 27. So minus we have plus, so we have plus 27 equal to 36. So everything is great. Our root is absolutely correct. So it was my solution to this question. I really hope you understand it, and if you're really interested in hints, if you're really interested in tricks, because this question has this is our cubic equation. So if we have cubic equation, we have 3 roots in total. It tells us the fundamental theorem of algebra. So what is the highest power? It means that many roots you can get from here. Okay, if we're talking about cube, it means 3 roots, and we have it. So it's like a proof from that angle, from angle of the theorem. Yeah, and if we have, for example, square right here, we have 2 roots. If we have linear function, we have only 1 root. And this is extremely important part, because a lot of students might be thinking maybe we have only 1 root. A lot of students try to solve this question by inspection, and they say a equal to minus 3 is true, but they forget about a complex part, because if you solve this question by inspection, which is, I don't stand this method, I don't like this inspection method. It's a great method when you want to check a root, check, for example, or if you don't have a time, you can use this inspection method. My quick recommendation, just practice this question, and then you can easily say, okay, I solved this question completely. I have complex part, I have real number part right here, I know fundamental theorem of algebra. That's why we can't get a fourth root from here, because this is a cubic equation, and you can easily be proud of yourself if you think like that. And it's also really great for you and for your teacher if you solve this question like that. So first of all, forget about the inspection method. Secondly, just spend like 2 or 3 minutes to think how can we work with it. Basically, with 100% probability, right here we need to group something. We need to group cubes, squares, and then with 100% probability, because this is basic question, so we can factor something and then product of 2 parentheses. It's also really great thing for us, because we can split it by 2 parts. By first part, linear part, very basic one, and secondly, quadratic equation with also a basic solution method of coefficients. And in the end, we have a classic solution. A lot of multiple times you can get 1 real number root, or 2 complex, or 2 real and 1 complex root. This is a basic answer to this question. So it was my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel. So we have a really great community, a lot of teachers here, a lot of students. So if you're interested in different answers, different questions, so you can easily go through this YouTube channel. A lot of things here, a lot of a really great community, a lot of teachers here, and a lot of students. So that's why I want to say thank you everyone for being here, for studying math, for learning math. Maybe a lot of students here, maybe preparing for exams, for entrance examination. A lot of people all over the world, they struggling with math. So that's why I make these videos, and I really hope this video is helpful for you. Maybe not a lot, maybe you learn a bit, but it's also really great result for you, and if you learn something. Yeah, so it was my few thoughts, and I really want to say thank you for being here and for supporting my channel. Once more, you can see a solution, so you can easily pause the video and write your thoughts. What do you think about it in the comments below? So wish you all the best in life, take care of yourself, and have a great day. See you in the next videos, and yeah,